Oftentimes, your posterior distribution will look similar to one of the distributions we already know or is in our tables. I will now explain the most common distribution used for problems, the beta distribution. Beta distribution has the following distribution. And for our purposes, theta is equal to 1. Therefore, our beta distribution will look like this. Notice that this part is always a constant. Therefore, we can write the distribution as fx equals to a times x to the a minus 1 times 1 minus x to the b minus 1 for some constant k. And we can also say that fx is proportional to x to the a minus 1 times 1 minus x to the b minus 1. Now take a look at the document solutions to book problems posted on the class website. We'll take a look at an example from number 15.100. Here we see that our posterior distribution is this, and we are asked to find the mean of the posterior distribution. One way to do this is to evaluate the integrals for a posterior distribution and taking the expectation using this formula. However, a smarter way is to realize that this distribution looks similar to a beta distribution. The denominator here is always a constant since it is a definite integral. Therefore, we can write our posterior distribution like this, for some constant c. And we can also say that our posterior distribution is proportional to q to the third times 1 minus q to the third. And this is a beta distribution with a equals 4 and b equals 4. We find a and b by matching this to that and this to that. And we get a equals 4 and b equals 4. Looking at the table, we see that to find the mean of the beta distribution, we only need to know a and b and k. Therefore, it is not necessary for us to calculate the c in our posterior distribution. Now you should be wondering if the k in our general beta distribution is equal to the c in our posterior distribution. The answer is yes, and here is a proof for that, for this particular example. And we see that they're both equal. Thank you.